Okay, this is 10.7, day 2. And I want you to start, excuse me, I want you to try this quiz in your concept book. Draw the figures, write the questions, and answer them. It's really nice to have another example of this kind in your book, in your notes. So please, if you're watching this on the video, pause and then come back and check your work. Okay, just a second. Who knows whether these two solids are similar? Are they similar?
Yes.
Okay, so who can give us the ratio? Give me a ratio that proves that. Read it.
54 equals 36 over 16.
Did anyone else set theirs up this way? Interesting. So you're showing that the dimensions of this larger cone are equal to the dimensions of the smaller cone when set up in the same way. You have height over radius equals height over radius. That's different than the earlier class. Who set this up differently? And Faith, what do you have?
I took 54 over 36 equals 24 over 16.
And who else has that one? A bunch of people. And so that is comparing figure, if I call this figure A and this little one B, it's figure A over B in heights equals figure A over B in radius, right? And so are these ratios all true? Does 54 over 24 equal 36 over 16? Brayden, did you test it?
Yeah.
And is it true?
Yeah.
Good. And so we could just simplify it, right? We could reduce things down and see if we have, what goes into both 54 and 24? All right? 2 does, for sure. 6 does too, right? So 6 goes into 54 9 times and into 24 4 times. Oh, so there was something bigger, huh? So what about, oh no, 9 and 4 are not reducible. What am I saying? That's it. And so what goes into 36 and 16? What goes into 36 and 16? 4 as well, right? So we have 9 over 4. So 9 over 4 equals 9 over 4. It's true. And then what do we get when we reduce 54 over 36? Did you do that, Faith?
Yeah.
Or you just divided it?
Yeah, I
Or-
just divided it. I don't know.
Okay, so she just divided the top by the bottom and both of them were 1.5. Another way to look at it, or you could say 3 over 2, right?
I did 36 over 54 and 6.
Okay, so if A to B has a scale factor of 1 to 3, we can write A to B a different way. How can we write it? Juliana?
A over B.
Good. A over B is how they're setting things up here. A over B, they're saying, has a scale factor K of 1 over 3, 1 to 3. Then they're giving us not just a single dimension, they're telling us A has a surface area of that. So what do we do with surface area when it comes to our K? What do we do? K is squared when it comes to surface area, right? And when it comes to volume, what do we do to the K? Cube it. Okay, so Juliana, tell us how to set up to find the surface area for B.
Okay. You do 1/3.
Finding surface area.
1/3 squared equals 112 over x. And then you square 1/3 and it's 1/9.
Good job.
112 over x. And then you get, you multiply 112 times 9, you get 1,008.
And 1 times x is x, right? And who has that? 1,008 centimeters squared. Excellent. Almost everyone.
Yes.
Okay. And let's try volume. Who could set that one up? Okay.
Yes. Okay. I did 1/3, and then I cubed it,
Good job.
and I got 1 over 27 equals 64 over x. And then I
And what are it's centimeters cubed, right? So,
And then I multiplied 27 by 64.
and 1 times x.
And
And what'd you get?
I got 1,728.
And excellent job. Who got that too? Everyone got that? Yay, we're all good. Excellent. You guys are doing so well. You don't need to write this question, but take a moment, freeze the video, think about this, and then we're going to come back and give our answer. So what does quadruple mean? What are we multiplying by? 4. So we're saying that, you have to know that, because that's in this question. We're producing a similar cylinder by multiplying all of the dimensions of the cylinder by 4. So what will that do to the volume when we quadruple all of the dimensions? 3. Are you going to give me a letter answer? Ready? 3, 2, 1.
C.
Who says C? Who says D? Who says A? Who says B? Wow, we have a little bit of everything here. The other class was totally confident and they got the right answer. Interesting. Maybe I talked about it a little bit more. I made them write it out. Hey, maybe I should have had you write that out. Okay, so we're saying that all of the dimensions are quadruple. And so what happens with volume when we're saying that we have a scale factor of 4. We're multiplying all dimensions by 4. And what do we do with volume with our scale factor? You just did it over here and you did it beautifully. What did you do here with the volume?
We cubed it.
You cubed it. So what will you do with your scale factor here?
Quadruple it.
No, you will cube it. Your scale factor though is 4, right? So what is 4 to the third?
64.
So good for you if you chose D. It's 64. Okay. Here's a follow-up question for you. Listening, Courtney, listening. What if I rewrote this question and I said, give the volume, what will happen to the volume when the dimensions are tripled? What will happen to the volume when the dimensions of the cylinder are tripled? Can you say the answer? They will be multiplied by,
27.
good job, you're cubing the 3 now, right? What will happen to surface area if I multiply all the dimensions by 5? What will happen to surface area if I multiply each dimension by 5? The answer is? Multiply by 25. Now you're squaring the 5. Okay? So when it comes to area, we square our factor, but when it comes to volume, what do? Cube it, right? Okay. Let's try this problem. You do need to pause and write this down. Okay? You have found a scale factor with 2-dimensional figures before. Now we're finding it with 3-dimensional figures. So they may give you 2 surface areas. They could also give you 2 volumes, right? So we have to keep in mind what we were just saying about what happens to the factor, scale factor, when we find area, or what happens to the scale factor when we find volume, right? So they want us to find the scale factor model to actual. So how do we set up that fraction, that ratio? When it's written this way, model to actual. What goes on the top? Model. We're going to make sure our scale factor looks like this. Model over actual, which is the most common way we find model question scales anyway, you know? Okay. So we know surface area right now. And so the scale factor that already was used here was the scale factor squared, right? So the scale factor, I'll disconnect, squared is somewhere hidden in this information already given. So they've asked us to put model over actual, so that's what we do. The model surface area is what?
3 feet squared.
So we put that here, 3 feet squared. And the actual surface area,
2,028 feet squared.
okay. So right away, what could we simplify?
Squared.
We could simplify these. And so that makes sense because scale factors don't usually have units. Scales have units sometimes. 1 inch equals 60 miles on a map. 1 inch to 60 miles. But scale factors we're multiplying by, they don't usually have 2 different units. Okay? So now the problem here is that we have k squared equaling something. So we don't really have the scale factor equaling something. We have the scale factor squared equaling something. See the problem? So what is the inverse of squaring a number? Square root. So we're going to take the square root of both sides. See that? And we end up, the square root of k squared is k. Those two are inverse operations, right? We just get the k factor out. And now we have the square root of 3 over the square root of 2028. And why don't we leave them separate? Now, could we divide 3 by 2028? Yes, but we won't have a ratio of this to that, right? We would just have one number we're taking the square root of, which we could say then is relative to 1, but anyway. What is the square root of 3? Let's round it to the 10th place. Square root of 3, 1.7. And the square root of 2028?
45. It'd be 45.0, so 45.
45.0. And what's the next number after 0?
3.
3. Okay, so good. So we could say we have a scale factor of 1.7 to 45. Actually, we could change this to just a single number, huh?
It'd be 2.
Go ahead and do the division. What would it be if we do the division? Dylan?
You said if you're getting it to 1, you can have 1.7
I'm saying divide 1.7 by 45. That's what we have here. 1.7 divided by 45. Do you have it, Tara? No? I want to hear this number and then I'll take a question. Rachel?
0.04.
So we could say that we have a scale factor of 0.04. All of the dimensions of the model, are 0.04 to the actual of 1. If we want to get rid of that decimal here, what can we do to the top and bottom? What would we do to get rid of the decimal in 0.04? Times by 100. Move it twice over, and you would have 4, but you would have to move the denominators by 100 as well. So 4 to 100. Oh, can you reduce that? How many 4s are in 100? So 1 over 25. But there's a nice way to look at it. There's a number of ways to reduce this. And so we did it kind of a funny way here, but anyway. Ultimately, we want a number versus another number, right? Okay, so you may begin.
That's it?
That's it, yeah.